All right, guys, a little quickie here today. I'm moving equipment around trying to make room where I have none. But I said the other day that there were some advantages and disadvantages to the digital readout that I'd put on the mill already, which is a ToAuto DRO. I think that's basically the same all the way across the board with these relatively inexpensive import digital readouts that we're putting on the machines. I've got one on the milling machine now, and I actually ordered one to go on this lathe, which will actually go on the other lathe once I get it rebuilt. But anyway, neither here nor there. I've been running these Shumatech digital readouts. This is the DRO 350, which is the early model, and I've run this one for, at least 10 years, however long they've been out. I've got several of these on different machines still. They upgraded them. Scott Shumat did an upgrade to the 550, which took glass scales with TTL signals on it. So this actually, the 350s, they make a dongle, and I've got a couple of the circuit boards that you can build to adapt them to put linear scales on, whether they're rotary encoders, linear scales, glass scales, whatever the case may be, magnetic scales, anything that puts out that TTL signal. Now, I've ordered a ToAuto DRO just like I've got on the mill to go on this lathe. The thing that I did not like about it, and one of my biggest complaints, was it does not sum the compound axis in with the rest of them. So, and I thought I'd demonstrate that here. Now on this 350, my complaint with it is, of course, I've let it get dirty. I haven't had good chip protection on the scales, which amounts to either the cheap Chinese imported scales or calipers that have been converted, that type of thing. So the thing that I really like about this Shumatech, that as I noticed today after I'd moved stuff around, I fired this DRO up, and it's doing exactly what it's supposed to be doing. Now, I think the glass scales are more stable. I think they give you faster response, and I think they're more stable. The downside, like I say, is that the glass scales on these cheap digital readouts do not sum up the compound. So I thought I'd demonstrate that real quick because it's doing it the way it's supposed to be doing. Now I've got a couple of these scales are off and not hooked up, so I'm just going to manually run them. But this would be our X scale, Z1 and Z2 scale. So the way I had this set up was I had this as my long axis. The Z1 is the cross slide on the lathe, and the Z2 is going to be the compound movement. So when you move left to right down the length of the lathe bed, why you get our reading up on the top. So, and this is running real stable on here. I've had some instances on some machines where they won't be real stable. I don't know if that's the digital readout, and there is buffering built in there that you can adjust. So this has always been pretty good, other than I had a 550 on here and it didn't want to perform as well. So then for our Y-axis scale, which is disconnected here, while you move it in and out, and it moves your cross slide, so it moves that scale. And of course we could zero these all out so we knew what we were doing. So our lathe bed, long lengthwise, our cross slide goes here. But now when we move the compound, which is this scale here, it'll change all three axes. And what it's doing is it's actually giving you the actual lathe tool positioning, you know, for where it is. It's taken into account your cross slide and your longitudinal length, because as you run the compound in, why it moves it both forward and to the side. So this kind of sums them up, and that's one of the things I really do like and I do use on this lathe. And you can set your compound angle in the settings while you set. So normally I'm running a 29, 30 degree compound on it, depending on, you know, exactly what I'm doing, if I'm cutting or something like that. So you can set whatever compound angle you want in there to match what you've got the compound set at. So my thinking is, even though, and I checked tracking today, the new read head is supposed to be here, and I have glass scales to go on this machine. What I was going to do, and what I may still do eventually, is I'm just going to use the X and the Y axis, the compound, or the long axis on the bed, parallel to the parallel to the spindle, then the cross slide, and I was going to use what would normally be the Z2 axis or the Z axis on a mill, and I was going to use that on my reader on the tailstock itself. So that's been one of my complaints. I just adapted a digital scale to, or a digital caliper to work as a tailstock digital readout. The downside to those is they go through batteries on those cheap scales there. So probably if I continue using this one, I'll take and adapt it so I've got power to that digital readout all the time on the, or that digital scale on the tailstock. So that'll take care of that. But that's what I was going to use the third axis on the digital readout for, was just mount a glass scale on that on the tailstock and do that. The digital calipers and scales that are on the lathe right now, they're powered through the digital readout. So I consider these to be old technology now. I consider them to basically be obsolete, but they do still have a place, and I'm deep enough into them that I may continue to run this one, just redo my mounting so I've got good shielding on all of them so that I don't get chips and crap on them, because that's the main failure point in them, is you just get oil and grease and crap on the readers, and then they don't want to read. It'll give you an overflow code or an error code, something in there. So anyway, quick and easy. Hopefully you find that interesting, if not useful. And that's kind of my thinking on scales for the lathe, or on digital readouts for the lathe. So hopefully you find it interesting. Comment, suggestion, guys, leave them in the comments section for me below. And as always, thanks for taking the time to watch.